Apparently it's becoming a quiet trend now. Lucky girls are getting wedding proposals under the aurora lights. No worries, I'm not here to talk about romance, I'm more fascinated by the phenomena itself. So let's dive in and understand how this magical celestial display really happens. The first thing we need to talk about is our star, the sun, which is at the heart of our solar system, and its gravity holds the entire system altogether. A hot, glowing ball of mostly hydrogen gas with many layers, starting from the core extending outward to the corona. At the core, the energy reaches up to 15 million degrees Celsius. It's very hot, where hydrogen is mostly ionized, and this is where the energy is produced by nuclear fusion, where hydrogen nuclei combines together to give us helium, releasing enormous energy. From the core, the energy passes through different layers, and they act mainly as energy transport zones. We have the radiative zone, the convective zone, the photosphere. The photosphere actually acts like a surface of the sun. The photosphere, this is where we believe that the visible light of the sun is coming from. The other layers actually produce or emit light, but it's too faint to see. We have the chromosphere. And then we have the corona. If you want to see the corona, you can look up at solar eclipses pictures. White halo around the sun is actually the corona. In the corona, magnetic fields lines form loops that trap ultra-hot gases, but sometimes these magnetic fields open up, allowing a stream of hot charged particles, mainly protons and electrons, to escape through coronal holes. And since we have coronal holes all over the corona, this results in a continuous outflow of particles called the solar winds, which expand outward from the corona to all directions in space. This is actually a normal thing happening on a daily basis. But during periods of increased solar activity, we have many of these particles. We have a high intensity of these particles, and we were talking about solar activity. We're talking about solar events like sunspots, solar flares, and CMEs. Let us understand a bit what are they. So the sun's photosphere that we already talked about, where darker, slightly cooler regions known as sunspots form. And sunspots are a region of intense magnetism on the solar surface, where magnetic fields become twisted and storing energy. When a sunspot interacts, they can release bursts of energy. Solar flares are eruption of energy that contains heat, magnetic energy, and ionizing radiations. These radiation, the solar flares, can reach up to Earth in few hours, but CMEs, coronal mass ejections, they can reach in many days, and it can get up to 3 days. And coronal mass ejections are more powerful. A huge burst of solar plasma and magnetic fields ejected from the corona into space. Now, the journey starts from the sun in space and then arriving Earth. Earth has a strong magnetic fields we call the magnetosphere, acting as a shield. It deflects most solar energetic particles radiation that is coming from the sun. So the magnetic fields couple together and create a funnel for gas to streams down to the pole, and this is where daylight aurora happen. Magnetic fields stretch further back and couple together again, forming the night light aurora. Gas streams along the magnetic lines toward the pole on the night side. But how are we getting really colors? Solar particles collide with atoms in the Earth's atmosphere. They transfer energy to these particles in a process known excitation. Incoming solar particles, mostly electrons and protons, energize the electron in atmospheric gases, causing them to move to higher energy levels. Then these electrons fall back to their original energy state. They release photons, this particle of light that creates the beautiful colors of the aurora. The specific colors depends on the type of gas and altitude. For example, oxygen and nitrogen, the main gases in the Earth's atmosphere, emits distinct colors. Green light is characteristic of oxygen, while nitrogen produces shades of purple and blue and pink. Occasionally, we see a scarlet red aurora caused by high-altitude oxygen interacting with solar particles, but this only occurs during particularly intense aurora. This is how really aurora comes to life from the intense sun's energy coming to Earth, and it is produced in our skies. So it's really amazing, the wedding proposal and the aurora, and I bet it is more fascinating and even romantic to understand the phenomenon happening above you. Thank you for watching.